Assalamualaikum and salam sejahtera to Dr. Farah Zayana. My name is Putri Ilya Maisarah and we are from group 25. Today, we will present about high performance liquid chromatography, or could be called as HPLC. So here are our team members: Nordiana Safia, me, Putri Ilya Maisarah, Alia Maisarah, Nick Suari and Alia Shamimi.
Introduction. High-performance liquid chromatography (HPLC) is a potent method for measuring, separating, and identifying a mixture constituent parts. It operates by passing a liquid sample through a stationary phase-fill column, while a mobile phase-fill liquid flows through it under high pressure. As the sample passes through the column, the stationary and mobile phases separate due to the distinct interaction between the various compounds in the sample. Because HPLC is accurate, dependable, and capable of handling complicated combination, it is widely utilized. It is frequently used to verify the safety and quality of product or to investigate chemical qualities in fields including drug testing, food quality analysis, environmental monitoring, and research labs. Objectives. First, to determine the retention time of a standard solution, caffeine. Second, to identify the caffeine peak in a soft drink sample. Third, to identify the amount of caffeine in soft drink sample using the response factor method.
So for the methodology, the mobile phase reservoir typically uses a glass bottle with special caps, Teflon tubing and filters. These connect to the pump inlet and deliver the solvent to the system. Purge gas like helium is used to remove dissolved gases, with asperger helping to degas the mobile phase for optimal flow. The mobile phase should be pure, low in viscosity, and compatible with the detection method. We must effectively dissolve sample components without reacting with them, ensuring smooth separation and accurate results. The pump's main function is to force the mobile phase through the column packing, ensuring continuous flow throughout the system. It maintains stable flow and helps avoid pulsation, which could affect the accuracy of the separation. There are several types of pumps used in chromatography: reciprocating pumps, displacement pumps, and pneumatic pumps. Injectors are used to introduce the sample into the mobile phase. Syringe injection, simple method using micro-syringes, can withstand up to 15,000 psi. Sampling loop, most common method, handles 5 to 500 and can operate under pressures up to 7,000 psi. For auto-samplers, automate sample injection, holding vials in a tray and injecting samples efficiently. For HPLC, there are two types of columns, analytical and guard column. The analytical column is the main component for separation in HPLC. It is made of stainless steel with a length of 10 to 30 centimeters, an integral diameter of 4 to 10 millimeter, and a particle size of 5 to 10 micrometer. The guard column protects the analytical column by preventing deactivation, clogging, and band broadening. It has larger particles to reduce pressure drop and a length of 2 to 10 centimeter. It also minimizes solvent loss and should be replaced periodically. HPLC detectors are classified into two main types: bulk property detector, respond to mobile phase properties like refractive index and density, which change due to solids. Second one, solid property detectors. Detect solid-specific properties like UV absorbance, fluorescence, or conductivity. Some widely used HPLC detectors include UV detector, measures UV or visible light absorption; refractive index detector, detects changes in refractive index; conductivity detector, measures ionic species; fluorescence detector, highly sensitive for fluorescent compounds; and mass spectrometric detector, identifies molecular weight and structure. The choice of detector depends on the sample's nature. UV detectors are the most commonly used due to their versatility.
Hi, my name is Nordiana Safia and I will explain about the result of HPLC. When analyzing caffeine using HPLC, the result typically include the retention time, peak area, and response factor to determine the concentration of caffeine in unknown samples. The chromatogram shows a peak at a retention time of 2.482 minutes. This slide presents the HPLC results for caffeine in Coke. The chromatogram shows a peak at a retention time of 2.481 minutes, which corresponds to caffeine. The numerical data table below the chromatogram provides further details, such as peak width, height, and area, which help quantify the caffeine concentration in the sample. Furthermore, this slide displays the HPLC analysis results for caffeine in Levita, another caffeinated beverage. The chromatogram shows a caffeine peak at 2.479 minutes, closely matching the caffeine standard. Similar to the previous slide, a table with a peak characteristic is included, providing essential data for caffeine quantification in Levita. Moreover, this summarizes the caffeine analysis result for both Coke and Levita, comparing them to a caffeine standard. The retention times for all samples are nearly identical, confirming the presence of caffeine. The peak area values indicate that Levita has a significantly higher caffeine content than Coke, as shown by its larger peak area. Calculation of caffeine concentration in different beverage samples using a response factor derived from a caffeine standard. The response factor is determined by dividing the peak area of the caffeine standard by its concentration 0.1 mg per ml, resulting in 62494.8779 mg per ml. The caffeine concentration in the Coke sample is calculated by dividing its peak area 7001.12305 by the response factor, resulting to 0.11203 mg per ml. Converting this to parts per million ppm by multiplying with 1000 gives 112.027 ppm. Similarly to this Levita sample, the peak area 151.1000 is divided by the response factor, giving 0.178432 mg per ml, which converts to 178.432 ppm. These calculations help quantify caffeine content in beverages, allowing for comparison and analysis.
Now for the discussion. So caffeine is used as a standard solution to compare with other solutions. So based on the HPLC chromatogram shows a single peak with a retention time of 2.482 minutes, which shows presence of caffeine in the solution. The sharp peak suggests minimal interference from other compounds, with a percentage area of 100% showing high purity. So based on the spectrum, we are able to interpret that the peak area is 6249.48779 MAU and the peak height is 1196.10278 MAU. So the first solution that we're looking at is Coke. So based on the HPLC chromatogram, it shows several multiple peaks with a major peak of 2.481 minutes, which corresponds to the caffeine based on the standard solution. Several smaller peaks at 1.940, 2.031 and 2.122 minutes indicate the presence of other compounds. So based on the spectrum, we are able to interpret that the peak area is 7001.1235 MAU and the peak height is 1465.57929 MAU. So the major peak contributes to 57.3551% of the total area. So by comparing this peak with the peak area of the caffeine solution, the estimated concentration of caffeine in Coke is found to be 112.027 ppm. The other peak suggests the presence of other compounds such as preservatives, sweeteners and flavoring agents. So the next solution is Levita. So based on the HPLC chromatogram, it displays multiple peaks showing various compounds. The major peak is at 2.479 minutes, which is closely matched to the retention time of the caffeine standard, which confirms the presence of caffeine in the solution. So based on the spectrum, the peak area is 11511.12 MAU, while the peak height is 2389.66479 MAU. So the major peak contributes to 17.6951% of the total area. So by comparing this peak with the standard solution, the estimated caffeine solution found in Levita is found to be 178.432 ppm. So the other peaks, it suggests the presence of other compounds such as taurine, B vitamins and other energy boosting ingredients.
So, as a conclusion, high performance liquid chromatography (HPLC) effectively identified and quantified caffeine in soft drink samples such as Coke and Levita by comparing retention times and peak areas with a caffeine standard. Caffeine concentration were estimated at 112.027 ppm in Coke and 178.432 ppm in Levita. Additional peaks indicated the presence of other compounds, such as preservatives and energy-boosting ingredients. The study demonstrated HPLC's precision, selectivity, and reliability in analyzing complex mixtures, making it a vital tool for quality control and chemical analysis in various industries. So that's all. Thank you for watching.